America's freight rail network is the world's safest, most reliable, and efficient mode of transport. The U.S. railroads maintain this edge in large part through advances in rail technology. And many of these breakthroughs are made by the railroads at their research and test facility, TTCI, the Transportation Technology Center Incorporated.
All set to go.
TTCI is owned by the Association of American Railroads and set on federal land in Pueblo, Colorado. Here, the engineers at TTCI's labs and test tracks are using rail tech to drive innovation and forge the future of the rail industry. In the facility's two main laboratories, engineers use one-of-a-kind test machines to simulate the stresses of long-term train operations. This gives customers data on component durability in weeks instead of years. Inside the component test lab, the inertia dynamometer is used to test railroad wheels, axles, and brakes to pass rigorous certification standards.
It's based on physics, so the large flywheels you see are all designed to simulate the mass of a train car. This is a 70-ton freight car.
Housed in the massive Rail Dynamics lab, the 660 machine is named for the 660,000 pounds of force it can apply to railcar suspension components, like side frames and bolsters.
It's virtually trying to push the components to their limits in a safe environment in the lab before they ever go out onto the rails.
The center plate tester evaluates center bowl lubricants and liners. It's a key tool in research to prevent rollover derailments.
We're actually going to try to go to 500. We're hoping it'll break about 450.
And the coupler test machine brings enormous pulling force to bear on knuckles and couplers, the components that link rail cars together.
In this facility, we are putting large stresses into railcar parts to ensure that they're going to be safe on the road. If we can find the weak parts here, then they won't fail in service.
In the Rail Dynamics lab, engineers can also test entire freight cars, not just their components. Huge cranes lift the cars right onto a machine called the Vibration Test Unit.
The Vibration Test Unit is a machine where you can put the suspension system, the wheels, the axles, the truck, and the entire car body on it, and then run it through the paces of its dynamic environment in real life.
FAST. It's where some of TTCI's most advanced technology is put to the test.
Well, FAST is the Facility for Accelerated Service Testing, and the name really says it all. The facility gives us a place where we can test rail and track components in an accelerated manner. We can do it in an accelerated manner because we run a heavy axle load train on a 2.7-mile loop.
Okay, Matt, system activated.
To keep FAST up and running safely and consistently through night and day operations, TTCI engineers have automated the locomotive. In this test environment only, the train is remotely controlled.
I'm in control of the train, start, stop. There's nobody in the cab. Basically everything's run off my computer inside my vehicle.
And placed around the test loop at FAST are some of the world's most cutting-edge trackside detectors.
The railroad industry really has made a tremendous leap forward. It's a game changer to have these wayside devices out on the tracks. Railroads can essentially perform a CAT scan of the cars within just a few minutes, online, without ever removing the cars from service.
As the train runs its circuit, detectors constantly inspect its components. And as it passes through the arch of the fully automated train scan system, every car in this train is scanned with machine vision technology.
This system uses an array of cameras in the track, on the sides of the track, and above the track to fully image the car 360 degrees around the car. The level of detail we can get from these cameras down to serial numbers on parts, pattern numbers, is remarkable.
Measurement detectors, like the wheel profile module and the brake shoe module, instantly gauge a wheel's integrity or detect wear and tear on a brake.
Today, with the technology we have, the capabilities we have to automate tasks that were done manually for hundreds of years, is remarkable.
While these detectors watch, this one listens. The trackside acoustic detection system, with its 12 microphones, can hear the difference between the sound of good wheel bearings and bad ones that may be about to fail and cause a serious accident. And engineers at the FAST site are also deploying the latest technology to make railway bridges safer and more durable.
We're always trying to keep our railroads safe, and we inspect our railroad bridges on an annual basis. We make our money hauling freight. If our bridge is out, we can't haul freight, so we take the job of preserving our bridges very seriously.
At a different TTCI test site, a trackside detector with a proven record of success uses ultrasonic technology to find internal flaws in rail wheels.
The cracked wheel detector is an automated system that looks for defects in the rail wheels of each car. We can inspect multiple cars in a fraction of the time that it would take to do an individual car inspection by hand.
It's inspecting the entire wheel in seconds. By doing this automatically, then you can actually increase the efficiency and the safety of railroad operations.
The U-Rail system is a detector that actually rides the rails. It uses high-energy lasers to generate signals that spot hidden flaws in rails.
We are really at the leading edge of high-tech development in the world. There are things being done here nobody else is doing.
There are so many new and wonderful things associated with the rail industry that are so very, very cutting edge in terms of technology. We look for the next innovation to come.